Hello, as I said in the previous video, I will be solving some problems on trigonometry. So here I am, I'm going to solve the tough questions from different properties of triangle chapter. Okay, so let's start with our very first question. It's given that if in a triangle tan A by 2 equal to 5 by 6 and tan B by 2 equal to 20 by 37. So these are the two things happening, A by 2 and tan B by 2. Then we need to find out which of them is correct. So whether it is 2a equal to b plus c, or a greater than b greater than c, or 2c equal to a plus b, or none of these correct. So this one is a tough one because of this particular option. So let's give it a try. So tan a by 2 is this and tan b by 2. So before we'll start with tan a plus b by 2. So this one you can calculate tan a plus tan b, 1 minus tan a tan b. So this is 5 by 6 plus 20 by 37. 1 minus 5 by 6 into 20 by 37. So this is 305 by 122. Okay, this part is done. Similarly, cot c by 2 we can find out. That is 305 by 122. That is tan c by 2 will be just the opposite, 122 by 305. That's it. So you can see that the tan a by 2 was 5 by 6. This one is greater than this. And this one is greater than this. So similarly, we can write if the angles of tan is greater than this. So a by 2 greater than b by 2 greater than c by 2. That is a greater than b greater than c with respect to angles, and there's a rule that if the angles are greater, so the corresponding sides will also be greater. So our option is this. So you can see that in our particular question we can utilize around 3 to 4 type of theoretical aspects in order to get our answer. Okay, let's solve the next one. Given that a equal to 5, b equal to 4, that's it. And tan c by 2 also they have given root over 7 by 9. They want us to find the c side. So this kind of thing happen. So how to start? Start with the angle. Put the formula. So what is the angle and side formula? With respect to tan c by 2 you have a formula. That is this, s minus a, s minus b, s into s minus c. Okay. And this one is the square formula, so I can put it like this. At the end, just put the values, and what we have to do, we can multiply 2 in the numerator and denominator. So 2s minus 2a, 2s minus 2b, 2s into 2s minus 2c, 7 by 9. So here 2s is, this part we can replace it by c minus 1. This part is as c plus 1. 2s is 9 plus c, and this part is 9 minus c. And when you are with this, we can find it very easily. That is c equal to 6. So these are the basic tricks we can always follow in this kind of trigonometrical sums with respect to properties of triangles. Now, a tough question from the previous ISI paper. Okay. So this question says there's a triangle ABC and sine A, sine B, sine C are in AP. Okay. So in a triangle, sine A, sine B, and sine C are in arithmetic progression. Okay. That's it. Then we have to find which of them are correct. Like the altitudes are in AP, the altitudes are in HP. The option A is HP, the medians in GP, and the medians in AP. So these are our basic 4 options. So here altitude means, what is altitude? Some of you may have a hiccup with this. So I'm solving the altitude segment here. This is the first part, the second, this is the third. Okay. So altitude means this one is the first. So if you take a point and just take a straight line which will cut the opposite side, that is becoming the altitude. Okay. This is E, this is F. So this is your P2 and this is your P3. So three altitudes we have, and according to the formula we know half into base into height, half into AP1, that is equal to half into BP2, and that is equal to half into BP3. So the all trick lies in the very first part. So A equal to what? You can write it from here, 2 delta by P1, B equal to 2 delta by P2, and C equal to 2 delta by P3. Now sin A, sin B, sin C are in AP. So that means ABC are also in AP. That means if ABC are particularly in AP, so 2 lambda by P1, 2 lambda by P2 and 2 lambda by P3 are also in AP. That means these all are cancelling out. So we can also write that following the process formula of AP. So these things also will be in AP. So that means P1, the altitude itself, are in HP. So if numbers are in AP, so their reciprocals will obviously in HP. So in this way we can solve a problem of this kind. Okay. Now we can proceed to the next question. This next question is about triangle, but this time they have given a bigger equation. Let's see how to solve it. So in a triangle of solutions, they have given the tan qx minus 3k tan square x minus 3 tan x plus k equal to 0. So then the triangle, they want us to tell the triangle type, whether it's isosceles, acute, equilateral, or none of these. So obviously none of this is a baseless option. It has to be within A, B, C. But there may be a possibility, a very slight possibility, if the triangle does not exist itself, then we may have a different kind of triangle. Let's see, let's solve it. So if we just see that, and they have also given that ABC are the solutions of the equation. So that is ABC are the solutions. So under these circumstances, if ABC are the solutions of the equation, so tan A, tan B, tan C are its roots. So in this equation, tan A, tan B, tan C are the roots. Okay, so some of these, like tan A plus tan B plus tan C equal to 3k, that's it. So we can also write that tan A, tan B, tan C, utilizing the formula of tan A plus tan B plus tan C, and tan A, tan C equal to minus 3, and the product of these three will be this, but the product equal to the sum. You know this, the product sign is a plus sign, so 3k equal to minus k, so 4k equal to 0, so k equal to also 0. So if k equal to 0, so tan A, tan B, tan C is 0. That means tan A equal to 0 or tan B equal to 0 or tan C equal to 0, which is not possible because any particular angle has to be 0. Hence, the triangle does not even exist. Okay, so this is the beauty of questions like this. I will be solving some more in my next video. Thank you.